So our next topic would be on data security and compliance in the cloud. So in this module, we will complete the following exercises. Number one is applying data security controls, and number two is investigating cloud compliance controls. And after completing this module, we should be able to define and describe encryption methods in a cloud context, hashing algorithms, digital signatures, and file integrity monitoring. Also define and describe segmentation and access control, encrypt files using hashcalc tool. We also could define and describe the impact of laws and regulations in cloud computing, in record management in the cloud, as well as data loss prevention, and navigate and explain the use of AWS Artifact. Okay, so for our first exercise, it would be on applying data security controls. So when you're working with data, you must ensure that it is kept secure, and data can be kept secure using different methods such as encryption, ensuring data integrity, enabling data classification, and limiting access to data to unauthorized parties. Now in this exercise, we will investigate how to encrypt files and discuss ways this could be utilized in a cloud context. So when it comes to cloud data security, number one is encryption. It is the process of converting plain text or clear text into ciphertext. While data is in use, it must be decrypted and decompressed. Now, data in transit and data at rest must be encrypted via strong algorithms. Alongside each piece of encrypted data, an encryption key will be used to decrypt this data. Now, there are two main encryption methods. Number one is server-side encryption. Now, this form of encryption is automatic and manages both encrypted data and the encryption key. In a cloud context, a cloud service provider will encrypt and decrypt this data both at rest and in transit. In the context of cloud computing, CSPs will encrypt all data being stored in their data center, which is then decrypted when accessed by someone with the correct permissions. Another encryption method is the client-side encryption. This form of encryption allows client devices to manage the encryption key instead, which speeds up file transmission speeds between servers and clients as the data no longer has to be decrypted before it is sent. With client-side encryption, efficient key management processes are necessary to maintain availability of encrypted data. This can be done via a third-party key escrow service, which will manage keys on your behalf. Number two is integrity. Now, another security control that should also be considered with cloud computing is that you can verify the integrity of your data. When accessing data on a third-party server inside a secure data center, such as one hosted by a CSP, you need to ensure that your data is unchanged when uploading and retrieving files. Now, there are a few methods to verify the integrity of your data, such as hashing algorithms. Now, these algorithms will encrypt your data to a specific key, then run back through the same algorithm to decrypt your data. Now, if the data remains unchanged, then so will the hashing algorithm. There are different hashing methods with varying levels of security, such as Message Digest 5 or MD5 and the Secure Hashing Algorithm or SHA. Another method would be through digital signatures. So in the context of data security, a digital signature is a combination of certificates and hashing algorithms that will provide you with a signature that only allows access to data, provided that another person can provide a certificate that can decrypt the data. Now, this verifies the data has not been tampered with when in transit between two parties. Another security control would be classification. Now, in terms of data security, allocating different classification levels to data is key. Data classification systems differ between organizations, but generally follow similar classification rules. An example of this is by the sensitivity of the data being transmitted, such as low or unclassified. Now, this refers to data that is in no way protected or confidential and can be transmitted without any encryption. Another one would be medium or confidential. Now, this refers to sensitive data and should only be accessed by people who need access. For example, this can include personal or private information that should be encrypted. Number three is high or secret. This data is very sensitive and should only be transmitted on a specific need to know basis. Alongside this type of data classification, extra steps will typically be taken to ensure that it does not fall into the wrong hands, such as signing non-disclosure agreements and further encryption and integrity management levels. Now, when implementing a classification method, you should also consider segmentation to ensure that sensitive data is kept separately from data classified at a lower level. This could be on a secure drive or a separate database in a cloud environment. When it comes to access control, data classification methods allow you to implement different access control policies. Now, these policies allow different users to access different levels of data depending on different criteria. This can include controls such as privileged access control. Now, this refers to a control that allows only specific users with certain permissions to access certain restricted pieces of data. For example, organizations may set a policy in a public cloud subscription that prevents anyone but an admin from viewing or making changes to a specific part of a cloud infrastructure. Another control would be the role-based access control. Now, like privileged access control, only specific roles can access certain data. For example, you could have two different departments set up in a public cloud subscription and then set a policy that only users from one group to access the data they need. Number three would be rule-based access control. This allows access to data based on rules and policies that a security administrator has implemented. Now, when a user attempts to access some data, the rules assigned on Access Control List or ACL are checked before granting access. And lastly, mandatory access control. Now, this method allows you to tag data with certain signatures that allow only users with the same tag to access that data. Now, this differs from other methods in that the data itself is the one that is tagged rather than individual users. Now, for our first task, we will use Hashcal to encrypt files. Now, hashes are one-way cryptographic algorithms that mask data with various characters based on the output of that data, processed through said algorithm. The two main hashes are MD5 and SHA. Now, Hashcal is a tool that allows you to check 13 popular hash and checksum algorithms. In this task, we'll learn how to use Hashcal. Now let's connect to this machine. There's a type to search. Where do you search from? So you search this one. Type here the search box. Bakit wala ako? Oh, dito pala. So, #calc desktop app. For the best match menu, click the notepad. And let's type in we are testing #calc. Go to File and Save As. Under Quick Access, select Desktop, and in the file name, click Save. Now minimize all the windows. Notice that the #me text is on the desktop. From the toolbar, click the notepad. Click File and then New to open another document using Notepad. Reduce the size of the entitled window and move the window to the top left hand corner of the screen. Para nasa right siya. So from the desktop, double click #me text and reduce it. Use the size notepad, move the window to the bottom left hand corner. This is not the left, nasa right siya. And let's open #calc. Now the entitled text file will be used to compare hashes created by #calc on #me.txt before and after you change it. So from #calc window, ensure that the data format drop-down is set to file, data format to file. And from the data field, select this button. From Find dialog box, click the Look In drop-down. And select Desktop. Scroll down the list and click the #me. Click Open. Notice that the HashMe text file details have been added to the data text box. Now you can select any algorithms you desire, but for this task, we just keep the default hash algorithms ticked and select calculate. Okay, so notice that the fields next to the ticked options have been populated. Now copy the MD5 and paste it to the untitled notepad. But there's no need to save this file. Now click into the HashMe notepad window. Leaving a space after the existing sentence, type the following. Ensure that you have one space in between the sentences and click save. Now from the HashCalc window, click calculate. Copy and paste the new MD file into the untitled notepad underneath the first hash. Now when you compare the two hashes, you will notice that they are not the same. This is because you changed the text of the HashMe text file by adding the second sentence and saving it. Delete it's fun, added in a step previously, and then save the file. Now click on calculate in the HashCalc again. Ensure you remove the space in between the sentences. Copy the MD5 and paste it in a new line in the entitled text. So compare the hashes on the first and third lines as opposed to the one above. They are identical. This is because the file was changed back to its original format. Therefore, its integrity is valid. Now this has been shown as an example of how to manually encrypt files. Although with server-side encryption as part of a public cloud, this will be automatically and fully managed by the cloud service provider. Right, so for exercise number 2, this will be about investigating cloud compliance controls. Now it is key that anything created and stored inside of a cloud is compliant with relevant regulatory standards. Now most organizations have retention policies for data such as personally identifiable information to ensure that they are compliant. In the context of cloud computing, data can be given a retention hold, which means that any resource tag this way will be retained for a time as specified by the hold, and then once expired, can be deleted. Now typically a management policy would be enabled that automatically deletes and destroys data that passed a retention period. Now, data can also be tagged by legal holds, which ensures that data is not deleted or overwritten. In public cloud subscriptions, you can add this tag to many different types of resources, such as an S3 object lock in AWS, which has an option for either legal or retention holds. Now, this ensures that the locked resource cannot be deleted or overridden as long as the lock is applied. Now, another term for this is write once, read many, or worm drive, which is a storage device that only allows data to be written onto it and retrieved for reading, but excludes anyone from editing that data, useful for archiving purposes. Now, these different options are part of what is known as record management, a term that refers to managing data for businesses, critical, and legal purposes. These policies exist to enforce compliance with regulations, as well as ensure that most recent and up to date versions of documentations are available at any time. Part of this is ensuring that data kept for regulatory purposes, typically documentation such as legal charters, business proposals, etc., are correctly versioned to ensure that all data modifications can be tracked and that the most up to date version of that data is available for anyone that might need it. Now, legal documentation can also be provided directly by CSPs for public clouds in the instance that regulatory body or auditor needs to verify a requirement is being met. Now, AWS Artifact, a database which stores Amazon's internal, can be accessed by users with specific privileges, which can in turn be shared to ensure compliance. Now, data loss prevention, or DLP, is a policy that exists to protect sensitive data, which is generally any information that can be used to track down to a specific user. This data should be protected against any unauthorized sharing, such as third-party attacks. Now, DLP, or data loss prevention, should be implemented at the policy level, such as content analysis policies, alongside data security controls to ensure that sensitive information is tagged as such and is protected. Now, a Cloud Access Security Broker, or CASB, is a service available in public cloud subscriptions that act as an agent to streamline all of these processes together. Now, a broker will handle all information, streamline cloud access security, provides visibility of secure applications. An example of this is Sky High Security CASB in AWS. Now, in this exercise, we will investigate AWS Artifact, S3 object locks, worm storage, and how to implement a Cloud Access Security Broker, CASB, in AWS. Now, let's open the Microsoft Edge. So when opening the browser, it will automatically direct you to the AWS portal. Now, the login credentials has already been provided, so a trial account does not need to be created. So once we're in the AWS app authentication page, just click on sign in without changing the automatically filled credentials. Now, click Services at the top left-hand corner of the page, and from the Services menu, select Security, Identity, and Compliance. So security, identity, and compliance, this one. Then click on artifact, or I think now it's AWS artifact, I think. Okay, so from the AWS artifact splash page, click view reports. And after a few moments, the reports table will populate with a list of reports available for download. Now in the find reports or search reports text box, search for PCI. The list should automatically update to reflect this search criteria. So the security, identity, and compliance section in AWS allows you to implement different controls and quick access to tools such as AWS Certificate Manager, Cognito, IAM, Audit Manager, etc. Now, however, access to these tools in a real-world environment will depend on your privileges, and due to restrictions in the lab environment, cannot be accessed. So this will filter the list to show you the most relevant search. Select the first report listed and click on download report. So notice that a permission required message is shown in this lab environment and restricts access to these reports. That's showing. So in a real-world environment, you could use this report to satisfy regulatory bodies that the resources and infrastructure created as part of this cloud subscription fulfills all requirements. And that's it. We have completed the data security and compliance in the cloud practice lab.